Welcome back to Upward RC. My name is Isaac Smith, and today we are going to be doing the build video for the SKYWING Edge 540 plug and play. Alright, so like I mentioned, this is the plug and play version of the SKYWING Edge 540, so there's much less assembly required for this plane than your typical ARF. So the point of this video today is to walk through what does need to be done in order to take a plug and play plane from SKYWING to actually getting it in the air and being ready to go fly. So I'm going to go ahead and as the first thing I'm going to do, I'm going to use my monocoat iron and I'm going to go over the seams on the monocoat to make sure that the seams are adhered well. So there are different temperature settings that you use depending on what you're doing with monocoat. And when you're just trying to make sure something is sealed down well, you're going to set your iron to 220 degrees because that is the temperature that the adhesive on the monocoat is activated. So we're not trying to shrink the monocoat right now. I'm going to deal with these wrinkles in a moment, but to start with, I'm just going to go over these seams and make sure all the spots where you see seams are sealed down well. Now it's important when you're doing this that you don't push down hard. You're just going to lightly go over the monocoat. If you start pushing down hard, it can damage the monocoat. So now that I've gone over the seams, now I want to start addressing some of these wrinkles that you see in the monocoat. Now, a lot of times these wrinkles are caused by fluctuations in temperature, from when you go out to the field and your plane sits in the sun, or if it's been stored for a while at the facility that shipped it to you, the monocoat can respond to the fluctuations in temperature. So if you own one of these like wooden aerobatic airplanes, it's very common that you have to that you need to know how to address wrinkles in your monocoat to keep it looking new for the life of the plane. So in order to shrink monocoat to take away these wrinkles, we want to go ahead and increase the temperature of our iron to 300 degrees. So while my iron is heating up, I did want to make a note that monocoat actually shrinks above 300 degrees, but it can shrink all the way up to 350 degrees. But if I were to go ahead and increase the temperature of my iron to 350 degrees now, I would already be reaching the max on temperature that this monocoat could shrink under. And what you want to do is you want to try to take the wrinkles out at the lowest temperature and then work your way up incrementally from there as wrinkles occur, so that you always have a little bit of wiggle room in the temperature that the monocoat can shrink under. Because if I went straight to 350 degrees, I would already shrink it the max it could be shrunk. And then if wrinkles came back, I would not be able to take them out because the monocoat's already been shrunk to the max temperature it can shrink under. All right, so it looks like the iron is hot, so I'm going to go ahead and start working on these wrinkles right here. So it is important to note before I start working on taking out these wrinkles that you can damage the monocoat if you press too hard on it while you are applying heat. So when we do this, we're going to want to just very gently go over these wrinkles and just let the heat from the iron do the work. We're not pressing hard at all. It takes some patience, but you can have really good results if you just apply some patience. So we can already see that this wrinkle looks much better. An important note, when you're applying heat to a seam, you want to be careful not to hold the heat on there too long, because if this monocoat on the seam starts shrinking, it can actually pull away, and we want to be careful and avoid that. So we're going to just be very careful when we're applying heat to a seam like this. And there you go. That wrinkle is no longer there. And that just was very light going over the wrinkle with the iron. I have the iron set to 300 degrees, and it took that wrinkle right out. So I'm going to go ahead and repeat that same process over the rest of the plane. So here is a close-up of afterwards, and I just wanted to show you guys how just some patience goes a long way. As you can see, there are no wrinkles whatsoever anymore. So now I'm moving on to installing the elevator, and I've put the wings on the plane so that I can measure from the edge of the wings to the elevator to just ensure that it is centered. Another note to make on these plug and play planes, the elevator, normally we would have to glue the hinge, but because the hinge is already glued, we can just take the elevator and put it straight on the plane. So what I was doing there is just wanted to ensure that the slot that the elevator sits in is holding it centered, and I'm not going to need to add any material to any side of the elevator or anything to make sure that it sits in its slot the way it needs to sit. And it is good the way it is. It is perfectly centered when measuring from both wingtips, and then also from the horizontal stabilizer to the vertical stabilizer. So the next step is going to be to use 30-minute epoxy to glue the elevator into the fuselage. And the reason I like to use 30-minute epoxy is because it gives you some time after gluing the elevator in to adjust it and just ensure that it is centered once again after you apply glue to it. So like I said, I am going to be using some 30-minute epoxy to glue the elevator on. I also wanted to make a note that I like to have some acetone on standby in case I get any glue on the airplane. Acetone is really good about getting glue off of covering. So I'm going to go ahead and mix up the epoxy. Now I'm going to apply some to the slot where the elevator goes in, put some on the elevator. I'm going to slide the elevator in, and then we're going to measure to make sure everything is centered. All right, now that I have applied glue to the elevator, I'm going to go ahead and remeasure everything just to ensure proper placement. So now that I have glued on the elevator, I'm going to let that set for a while, and then I am going to go back and apply some CA along the edges to just seal everything up well. But I wanted to put epoxy on first and let that set up before applying any CA. Okay, so now that the epoxy has had an adequate time to dry, I'm just going to take some medium CA and I'm just going to go along the seam here just to make sure that that seam is filled in real well. An important point is that I'm not going to use any kicker or activator, whatever you want to call it, on this CA because I want to make sure it has time to seep into this crack here. So I don't want to activate it and make it dry real fast when I want to give it time to seep in there. And now I'm going to repeat the same thing for the bottom of the elevator. So I'm going to skip installing the rudder for right now because I just realized I don't have any thin CA. So I've got to make a run to the hobby store to get some thin CA to install the rudder. So I'm going to go ahead and start on the landing gear. So there are 2 Allen screws that hold the landing gear on. I'm going to go ahead and pull those Allen screws out, put some Loctite on them, and then install this landing gear. I'm going to put some blue Loctite on these screws and then go ahead and install them. So make sure when you are screwing in these bolts that if you run into some resistance, don't just force it because you're liable to cross thread the nut on the other side. They should go in pretty easily. So if you're running into a lot of resistance, I recommend making sure that you're screwing the bolt in straight and not cross threading it. Okay, so the next thing I'm going to do is install the spinner. So the spinner just has 2 Allen screws that are used to install it. The back plate for the spinner is already installed. So I'm just going to, like I did with the landing gear, put some blue Loctite on these screws and then just screw it on. So I wanted to make a note that this spinner has a little tab right here, which at first I wondered if it was some extra plastic that needed to be shaved off, but it actually helps you align your spinner so that when you put it on, it doesn't move side to side, so it already is lined up with the screw holes perfectly. So I really like that. All right, so now I'm going to mount the control arm for the elevator onto the servo. So I'm going to go ahead and take the Allen screw that's in the servo out, put some blue Loctite on it. I'm also going to center the servo by giving it some power while plugging it into the receiver and powering up the receiver. And then I'm going to go ahead and screw in the control arm. All right, so as you can see, the elevator is not really centered. So I'm going to go ahead and go into my sub trim settings on my radio and go ahead and use my sub trim to center the servo. That looks pretty close to perfect. When I first plugged in my battery and was trying to set up the motor, when I would give it throttle, it would not throttle up at all. It would just rev up a little bit. And I started doing some research and I realized that I think the ESC either needed to be calibrated or just reset. What I ended up doing was just resetting it to the factory settings. So the way that I did that is I had to program the ESC using the programming feature, and I'm going to walk you through right now what I did. I set it up off camera, so it's working for me now, but I'm going to go ahead and repeat the process to reset your ESC to the factory settings if you're in a similar situation where your motor is not throttling up correctly. I'm just showing you what I did. There may be a better way to do this, but this is what I did. So we're going to go ahead and before we plug in the battery, we're going to want to put the throttle all the way up. And then we're also going to want to flip the throttle cut. If you have a throttle cut on your radio, flip it off so that it is getting power. And now we're going to walk through a sequence of beeps that are going to tell us when we are in the setting to reset it to the factory settings. So that may be a little confusing. I can put a pop-up on the screen of all the different beeps we're going to listen to, but essentially we're going to listen to when we hear 4 long beeps, and then we're going to pull the throttle stick down, and that's what's going to reset it to the factory settings. So let's go ahead and do that. So you hear that 2 beeps. That's how we know it's going into programming mode. Then you heard that chime. That lets us know that it is now entering into program mode. So now we just have to wait till we hear those 4 continuous beeps. These are fast beeps. That was 1 long continuous. It's 1 long and 1 short. We're actually waiting for 3 long and 1 short. These are 1 long, and now we're going to get 1 long and 3 short. Yep. too long. So that's the one we were listening for. I'm going to pull the throttle stick down and it is now reset. I should be able to unplug the battery and plug it back in. Now I'll give it a little throttle. And it's working as it should. Alright, so now we need to install the rudder into the vertical stabilizer using the pre-installed CA hinges on the rudder. So these are already glued in, so we just need to glue them on to the vertical stabilizer. Now I did want to make a note, some of these airplanes come with a little piece that you can put in here that fills in the gap. This airplane specifically did not come with it. But if you have a plane and if you're following along this video building your plane, make sure that before you put the rudder on, make sure you check your kit to make sure that there's not the little piece of wood that slides into this slot to fill in that gap. Alright, so I'm going to go ahead and line up the CA hinges with the pre-cut slots, being very careful not to force it in. If I were to run across a slot that the CA hinge was not going in smoothly, then I am going to get a knife and open up the slot. But let's see here. Alright, so the hinges went into each slot just fine. Did not have to push very hard at all. Now I do want to make a note. You want to make sure you align the top here. Make sure that there's a flush fit from the rudder onto the vertical stabilizer. Make sure that the gap is not too large. Make sure that if you move the rudder, there's no interference in the gap. All right, it looks like we're good here. So now we're going to get thin CA. Very important to use thin CA. Any other CA is not going to work for this. And we are going to just open up the gap right here. And we're going to put 3 drops of thin CA on each hinge. Now I do want to make a note as far as how I'm determining the gap right here. I really have just pushed the rudder as close as it will go and then just opened it up a little bit by bending the rudder. But there really is almost no gap between the rudder and the vertical stabilizer. Another point, you don't want to try to do this with the regular tip that comes on the CA bottle. You need to use the applicator tip, one of these thin applicator tips, because the CA is like water, and if you don't have one of these tips, it's just going to go everywhere. And I've also got some acetone. This is actually some of my wife's fingernail polish remover, but it is 100% acetone. I've got some of that on standby. If I get any on the covering, that acetone will take it off. All right, so here we go. All right, so there's 2 sides to the CA hinge. I'm actually doing basically 2 drops per side. So I will say I've done this before on other airplanes. It's very tempting to put too much CA on there. That's why I kind of base the amount I'm putting on in drops. because if you just start putting CA on there, it absorbs into that CA hinge really fast. And I've made the mistake before of thinking that I didn't have enough in there, and I kept putting it on. And then later I turned the aircraft over and it had all leaked out the other side and was leaking all over the covering. So really try not to put too much CA on here, because this stuff will go everywhere, and it doesn't take much to activate these hinges and have them very secure. So I've put all the CA on the hinge. I'm just going to let this sit for a little bit. And I'm going to go ahead and rotate the plane over now, though, to make sure that it didn't leak through on the other side or anything. But I'm not going to hook up the servo until I've let it sit for a little bit. I don't know if you can see it on camera. I just wanted to point out that if you do it the way I just showed you, it did not make a mess at all. It did not leak through on the other side. The gap is very, very small. And it turned out really, really well. Really does not take much CA at all to do this the right way. All right, so when I put the rudder on, I did make a mistake. Forgot to put the tail wheel part in the hole that it goes into on here. Not a big deal, because I can take this part of the tail wheel off and do it now. So I just gotta undo these little Allen lock screws. And this part just slides right off. I did want to show, in case anyone was wondering, I don't know if you can really see it on camera. All right, it's not really showing up, but there is a flat side on this tail wheel. So these Allen screws are going to sit on that flat side and hold this tail wheel in place really well. So I tightened the Allen screws down on each side, but now I'm going to take them out one at a time and just add some blue Loctite to them. Now that the hinges on the rudder have had enough time to dry, I'm going to go ahead and install the push rod on the servo. I've already centered the servo. I've already took the screw out that mounts the control arm to the servo. So I'm just going to hold the counterbalance and the vertical stabilizer like this to hold the rudder centered. And now I'm just going to find the closest place to center on the servo. Now it's important that when you find center for the servo, it's more important that your servo is at a 90-degree angle than it is for the rudder to be centered. We can go back later and adjust the push rod size to get the rudder in the right place. So I'm not using any Loctite. I'm going to go ahead and put the screw in, and I'm going to power up the servo, get everything centered, and then come back and put some Loctite on there. So in this case, the rudder is not straight at the top. As you can see, it's a little bit off-centered, but instead of manipulating the push rod, I'm going to start by using sub trim, because I can see that the control arm is not perfectly at a 90-degree angle. So that is perfectly centered on the rudder, and we can see that the control arm is much closer to 90 degrees now. Okay, so I did a few things off camera, mainly setting up the servos. I did that off camera because I used my phone as a pitch gauge to determine the travel adjustment for the control surfaces. So the way I did it was I get some electrical tape and I just tape my phone onto the control surface, and then I use the Measure app on iPhone, and it'll, as you move the control surface, the phone will move with it, and you can check your pitch that way and set your endpoints. So for the ailerons, I have the endpoint set to be 37 degrees both ways. So you can kind of see Now, about what that looks like just visually. One more note about the ailerons. The way I came up with 37 degrees, that's a pretty standard number to use on ailerons. It's kind of known that if you're going for the fastest roll rate on these 3D type planes, if you go much above 37%, you're actually going to slow the roll rate down, because the ailerons are going to start acting more as an air brake than they are actually giving you more control authority in the air. So that's where I came up with that 37%. I'm just copying what other people have done and what is considered to be standard for these types of planes. As far as setting up the endpoints on the tail, this one is more opinionated, I think, depending on who you talk to as far as what the pitch should be for the extent of travel on the tail. For me, I just maxed out the throw on the elevator, down elevator, and that came out to around 50, I think it was 55 degrees. So that's what it looks like. And then up elevator, I could get a lot more than 55 degrees if I wanted to, but I wanted to match the pitch up and down so that if I'm doing a rolling Harrier or something like that, the elevator is pretty balanced from when you're upside down to right side up. Now I realize it's a little bit harder to tell on the elevator because, you know, your center of gravity has a big role in how it feels. But that was just my personal preference, is that I like to keep the pitch on the elevator close to the same up and down. On the rudder, the issue I was running into with the rudder was that when I moved the rudder to its fullest extent, even if it wasn't touching the elevator, when I moved it to the fullest extent, if it moved really fast, the momentum would make it slam into the elevator. And I didn't want that happening. I didn't want it to bind with the elevator or anything like that. So I ended up setting the pitch on the rudder to be 45 degrees each way. And that seems like plenty adequate for rudder authority. Obviously, you know, I'm going to get this in the air, and I may make some adjustments to those control throws once I see how the plane behaves in the air. Okay, so I quickly wanted to talk about a few things I did to finish the setup inside the airplane, mainly with the receiver. So I ran the wires underneath this piece of wood right here just to keep everything clean, and then I have the receiver mounted on with some double-sided tape. I was going to put a cable tie over the receiver, but it is really secure. It feels like I'm actually going to break the wood underneath it if I were to try to pull it off. So I didn't feel like a cable tie was necessary. Also, this receiver has a button on top of it, which is the bind button. I didn't want to run into any issues of the zip tie if I put a zip tie on there, pushing on that button at all. So as far as what is going into all of the channels, it's set up as you would expect, with the only maybe differences being this airplane has a separate power line for the BEC coming off of the ESC, so that wire went into the battery port. And then also the kit came with a capacitor, and that just plugs into any open channel on the receiver. In this case, I had a 6-channel receiver. This plane only takes 5 channels, so I had an extra channel that I was able to use. And that capacitor really just adds another layer of redundancy for your receiver. As far as battery placement, and CG, if you see right here, they have a mark pointing to the wing tube as far as determining CG. And in order to achieve that, I actually had to move the battery all the way back to the plug right here. So with that, I am a little bit concerned that if I need to move the CG back at all, I can't really move the battery back because the plug mount is in the way. But you know, if that ends up being an issue, I will deal with that when it comes. It looks like I might be able to loosen the bolts that hold this plug in and slide the plug back some. But hopefully just having the CG on the wing tube will be perfect. So I'm not too worried about that. And then I also did put Velcro on the plane as well to just add some security. it's normally not a good idea to use just a battery strap. So the kit came with some extra Velcro, but I like to use the Velcro that I have because it goes with the Velcro that is already on my batteries. And then I also like to be able to put 2 strips down, like you can see right there side by side. And what came in the kit would have only allowed for 1 strip. So I just like the added security of having 2 strips of Velcro in there. So overall, this plane went together very easily. I would say it took me a little bit more time than normal just because I was videotaping the process. But if I just was focusing on getting it done, I think I could have gotten it all done in one evening. If there's anything that I have as far as a complaint goes with this plane, just from the setup, would be that there's a little bit more play in the control surfaces than I would like. As you can see, there's some play in there, and I spent some time trying to see what might be causing that play, and I pretty much determined that it was just a combination of maybe the servo having a little bit of play in it, as well as the control arm, as well as the push rod. So when you have control arms that are as long as the ones that are on here, even the slightest bit of play makes a big difference. So here's the rudder. It's a little bit less than the elevator. I wanted to show you, like you really can't even see anything moving. It's just the fact that it's really hard not to have any play in the push rods and control horn setup. So that would probably be my only complaint. I don't know if it'll make much of a difference in flight, but I guess that might just be me being picky, but I wish that there wasn't any play whatsoever in the control surfaces, but there is a little bit. Well, that concludes the build video for the plug-and-play SKYWING Edge 540 61-inch. Thank you all for watching. Please don't forget to subscribe. I have another video on my channel about me doing an unboxing of this plane, and then also there will be some flight videos of it coming up soon. So thank you again for watching, and until next time, happy flying.